Week 1, Topic 1. Physical properties and classification of soil. For Topic 1, we will cover from Week 1 to Week 4. For this subject, we have two program outcomes, which is PO1 and also PO2. So you may refer the description for PO1 and PO2 here. Course outcomes for this subject, we have CO1 and also CO2. CO1 is applied physical and engineering properties knowledge through wide application of soil mechanics. CO2 evaluate soil behavior including flow of water through soil, shear strength, compaction and consolidation from the standpoint of effective stress concept. Okay, CO mapping as we mentioned before, CO1 to PO1, CO2 and PO2. Now we go for the learning outcome. At the end of this lecture, students should be able to understand the origin of soil, weathering of rock, and the formations of residual and transported soils. This subject is soil mechanics, so first you have to know what is soil mechanics and what is the difference between soil mechanics and soil engineering, and what is geotechnical engineering. Is it there a relationship between soil mechanics, soil engineering and geotechnical engineering? What is the similarities and what is the difference? And you have to find out. Alright, now we go for the soil mechanics. Soil mechanics is a branch of science that deal with the study of the physical properties of soil and the behavior of soil masses subjected to various types of forces. Remember, subjected to various types of forces. Soil engineering is application of the principle of soil mechanics to practical problems. So, soil mechanics is science and physical properties of soil. Soil engineering is application of the principle of soil mechanics. And geotechnical engineering, the science and practice of the part of civil engineering that involve natural material found close to the surface of the earth, including application of fundamental principle of soil mechanics and also rock mechanics. So geotechnical engineering, it covers rock mechanics and soil mechanics. Okay, now we go for the types of geotechnical structure. Okay, we have four basic types of geotechnical structure. First is foundation. Okay, if you see here, the foundation here, okay, this is, we have the concrete steel column at the top, and then we have the foundation at the bottom. Alright, so, okay, transmit load to the ground. Basic criterion is settlement should be relatively small. Variables, we have load, the size of base and depth. Second is slope stability. Okay, if you see here, this one is slope. Okay, this is the slope fall. Okay, this one is slope failure, and the mechanism of slope. Okay, you have the force here, you have the C, you have the phi, and then you have the angle. And then you have to do some calculation to know the slope gradient. And then you have to know what is the factor of safety. Alright, so we go for the slope stability. May be formed naturally by erosion or built by excavation or filling. Basic variables is slope angle and height. Okay, so we have the slope angle here, and then so we have height. Design requirement, slope should be not filled by sliding. Okay, this one is another structure which is retaining walls. Okay, this one is example of retaining wall. If you see here, okay, near the slope area, we have the retaining wall to make sure that it will retain the soil so that it's not fail. So for retaining wall, we have the here, this is analysis for the retaining wall. We have the active pressure, passive pressure, and then the force. Alright, so retaining wall is slope that are too deep and too steep to stand unsupported, can be supported by retaining walls. Basic variables, height of wall and its depth of burial, together with the strength and stiffness of the wall. Okay, so for retaining wall, of course, we have the horizontal stress. Okay, the last structure is earth fill dam. Okay, if you see here, this one is example of dam and how this one is actually the flow net. We will cover this chapter after this. Okay, this one example of dam. In any structure where there are different level of water, such as in a dam or around a pump well, there will be seepage of water. The seepage causes leakage through a dam and govern the yield of the well, and it's also govern the variation of pressure in the groundwater. So if there are pressure in the groundwater, of course we have to do some analysis to determine the permeability and also seepage. Definition of soil. Soil is defined as the uncemented aggregate of minerals, grain, and decay organic matter. Okay, for example, is solid particles along with the water, liquid, and air, gas, that occupy the empty spaces. Empty spaces we call as a void between the solid particles. So if you see here, for definition of solid soil, we have combination of air, water, and also soil solids. Okay, air and water is in void area, which is the empty spaces. Soil origin. Okay, soil occur very near the surface of the earth, are essentially the product of the action of weather and climates of rock. So means that soil is the product of rock. So there are it is formed by weathering and disintegration of rocks. Soil originate from the solid rock, such as igneous, metamorphic, and sedimentary. Okay, this one is already learned in the geology subject. Okay, so if you see here, this one is soil is formed by process of weathering, disintegration, their transportation, cementation, and everything. Okay, weathering of rocks. Okay, when we're talking of about a weathering, it's defined as the disintegration of rock near the Earth's surface through physical, chemical, and biological processes induced or modified by wind, water, and climates. There are three types of weathering. First is physical weathering, second is chemical weathering, and the last one is biological weathering. Mechanical or physical weathering involve the breakdown of rocks and soil through physical process including running water, wind, ocean wave, glacier ice, frost, and expansion and contraction by the gain and loss of heat. Second type of weathering is chemical weathering, involve the chemical decomposition of the original rocks. The original material may be changed to something entirely different. For example, chemical weathering of feldspar can produce clay minerals. And the last one is biological weathering. It's the effect of living thing. Okay, for example, of living thing is a plant, animals, and microbes. Okay, if you see here, this one is the roots. Okay, roots of the tree extend into the ground. They can press rock apart. So you see here, this one we have rock, and then it will be break the rock. Okay, and then this one is the example of chemical weathering, and this one is the mechanical weathering. Okay, if you see here, this one is original rock, and then there are water and ice here. There are frost and expansion and contraction, gain and loss of heat. So what happened is it will weather the rocks. Okay, you may refer to the physical weathering in this link, and chemical weathering, example of biological weathering here. Factors controlling the process of soil formation. First is natural and composition of the parent rock, climate condition, the temperature. If the temperature is high, the process of weathering will be faster. Okay, the humidity, topographic and general terrain condition, exposed density, type of vegetation, it will affect the process of soil formation. Alright, length of time related to particular prevailing condition, interference by the other agencies, for example, earthquake. Okay, mode and condition of transport. Mode of condition of transport, for example, wind, water, river, and so on. Alright, now we go for the type of soil. First we have the residual soils and also transported soils. So what is the difference between residual and transported? Residual, you have to remember that there is soil derived from the in situ weathering and decomposition of rock or rock fragment that has not been transported from its original location. So means that the parent rock is being weathered by process of disintegration and so on. For example, bentonite is type of chemically weathered volcanic ash that is present on the parent rock from which it is formed. And how about the transported soil? The soil has been transported away from its place of origin by wind, water, or any other agency that has been redeposited elsewhere. For example, alluvial soil are eroded from the hills by river and deposited from suspension in running water in the plain below. Uh, Three stages involve in formation of transported soil, which are weathering, transportation, and deposition of weathered material. Transported soil may be classified into several groups depending on their mode of transportation and deposition. Okay, this is an example of transported transported soil groups. Okay, we have the alien soil, marine soil, glacial soil, alluvial soil, lacustrine soil, and colluvial soil. So you may refer here what is the definition of this type of soil. Okay, this is example of alien soil. This one is marine soil. Alright, this one is engineering soil terminology. Okay, so here rock, hard rigid deposit forming part of the earth crust. For example, igneous, metamorphic, and sedimentary rock. Soil, any loose or diggable material that is worked on, and worked with. Organic soil is a mixture of mineral grain and organic materials, or mainly vegetable origin in varying stages of decomposition. Peat made up entirely of organic matter, very spongy, highly compressibility and compressible and combustible. And the last one is residual soil, the weathered remain of the rock that have undergone no transportation, normally sandy or gravelly with high concentration of oxide. Alluvium, sand and gravel which have been deposited from rivers or streams. Cohesive soil, fine soil containing sufficient clay or silt particles to impart significant plasticity and cohesion. Okay, this one is actually cohesive soil, and cohesionless soil is type of soil. Coarse soil, sand and gravel which do not exhibit plasticity or cohesion. Boulders, clay, also called till, soil of glacial origin consisting of a very wide range of particle size from finely ground rock, flour to boulders. Remember, excellence is not a skill, it is an attitude. Thank you guys.